March 1943, Kummersdorf, Germany. The Wehrmacht Weapons Testing Facility. The 5 American M1 rocket launchers captured at Kasserine Pass in Tunisia arrive in Berlin on February 28, 1943, 14 days after they were taken from soldiers of the 1st Armored Division who abandoned them during the retreat. German military engineers at Kummersdorf disassemble them within 48 hours. They are experienced men. The Kummersdorf facility had been evaluating weapons for the German army since before the First World War. Its engineers had studied captured Allied weapons throughout the current conflict: British Bren guns from Dunkirk, Soviet PPSH submachine guns from the Eastern Front, captured American rifles and machine guns from the North African campaign. They know how to read a design, identify its operating principles, assess its production requirements, and determine whether an enemy has done something interesting or merely different. Their analysis of the M1 bazooka, preserved in German ordnance records and recovered by Allied intelligence teams after the war, is brief, precise, and devastating. The American rocket launcher represents a simple solution to infantry anti-tank capability. Weight, 6 kilograms. Production requirements, minimal. Effectiveness, penetrates 80 millimeters of armor at 100 meters. This weapon can be mass-produced using basic industrial facilities. The engineers understood instantly what they were looking at. They did what engineers of any competence would do. They built a better version. They enlarged the warhead from 60 millimeters to 88 millimeters. They increased armor penetration from 80 millimeters to 160. They named it the Raketen Panzerbuchse, rocket anti-tank rifle, and gave it the operational nickname that revealed more than its designers intended: Panzerschreck, tank terror. The Germans had looked at a weapon designed to terrify tank crews and named their copy after the feeling it produced. They had understood the psychological dimension exactly. They had improved on the original in every measurable specification, and then they went into production and discovered the thing the Americans had not needed to solve, because the American design solved it automatically. The Panzerschreck's rocket motor did not burn out inside the tube. It kept burning after the round left the launcher. The exhaust came back of the operator's face in a jet of hot propellant gas, burning anyone within the backblast cone who was not wearing protective equipment. The early Panzerschreck required its operators to wear a gas mask, heavy gloves, and a protective poncho before firing. Anyone within 10 meters directly behind the weapon risked serious burns. The American M1 bazooka's rocket completed its burn inside the tube. The operator felt no backblast, no gas mask, no poncho. No gloves, just point and fire. Germany had built a weapon that was technically superior in every specification on the datasheet and operationally inferior in the one thing that mattered in the field: you could fire the American version without burning yourself. This detail, so small it appears as a footnote in most technical histories, is the most precise description of the difference between the two programs. The Americans had not set out to build the world's most capable infantry anti-tank weapon. They had set out to build the most practical one. The Germans, with more resources and more engineering talent, had built the more capable one, and then had to issue gas masks with it. This is the forensic account of how that happened, what it decided, and why Dwight Eisenhower, in a conference room in Paris in April 1952, placed a $25 tube alongside the atomic bomb on a list of 4 things that won the Second World War. April 11, 1952, Paris. A conference room of generals and defense strategists from a dozen Allied nations. Eisenhower is not talking about nuclear weapons or jet fighters or aircraft carriers. He is talking about a steel tube. The bazooka, he tells the room, was one of the 4 tools of victory. He places it alongside the Jeep, the C-47 transport plane, and the atomic bomb. The atomic bomb, the weapon that ended the Pacific War with 2 flashes of light, and a metal tube that cost $25. To understand why Eisenhower's list makes sense, you first have to understand the problem the tube solved. Because in December 1941, when the United States entered the war, the average American infantryman facing an enemy tank had one option that the training manuals were too embarrassed to state directly. He had to wait. Not for reinforcements, not for artillery. Wait, specifically for the tank to get close enough that a hand grenade thrown with everything he had might do something useful against steel plate that was specifically designed to deflect hand grenades. American infantry anti-tank doctrine in 1941, stripped of its tactical language, was this: if enemy tanks appear and no friendly tanks or anti-tank guns are available, throw grenades. If you cannot reach the tank with a grenade, withdraw. If you cannot withdraw, the manuals did not continue past that point. The British had learned the same lesson in the desert. Their Boy's anti-tank rifle, a bolt-action weapon weighing 36 pounds, could barely scratch the paint on a Panzer III at combat range. The Soviets had the PTRD, a 14.5mm rifle that required a strong man to absorb its recoil and could only penetrate lighter armor at ranges that put the shooter within machine gun range of the vehicle. Both weapons were, in the professional assessment of the officers who carried their after-action reports, gestures of defiance dressed as solutions. The United States Army was about to send millions of young men across oceans to fight an enemy whose tanks had broken Poland in 3 weeks, France in 6, and had driven 600 miles into the Soviet Union in the first months of Barbarossa. The standard counter to those tanks was throw grenades and hope. Someone needed to solve this. The solution came from a scrap pile. Edward Uhl was 23 years old in the spring of 1942. He had graduated with honors from Lehigh University the previous year with a degree in engineering physics, enlisted immediately after graduation, and been commissioned into the Ordnance Corps, and assigned to a special weapons development unit at the Army's facility in Indian Head, Maryland. He was working under Colonel Leslie Skinner, a career ordnance officer who had spent years thinking about rockets and shaped charges and the mathematical relationship between explosive geometry and armor penetration. Skinner had given Uhl a specific problem, the M10 shaped charge grenade, a weapon that worked, that could penetrate several inches of tank armor if it detonated flush against the plate, that no one could get close enough to the tank to use without being shot. The grenade weighed 3.5 pounds. You could not throw it far enough to be safe from the blast. You could not launch it from a rifle without destroying the stock and your shoulder with the recoil. Every conventional approach produced the same result, a weapon that worked at the range where you were already dead. Uhl needed a way to deliver the grenade from a safer distance without conventional propulsion. He described the moment of solution in the same terms every time he told the story, from his first post-war interviews through his final accounts before his death in 2010. He was walking past a scrap pile behind the workshop and saw a steel tube, 5 feet long, 60 millimeters in diameter, the same diameter as the M10 grenade he was trying to launch. He picked it up. He said out loud, to no one, "That's the answer. Put the tube on a soldier's shoulder with the rocket inside, and away it goes." The insight was not the tube itself. The tube was a piece of scrap. The insight was the geometry, a tube long enough that a rocket motor could complete its burn before the warhead exited the front end, producing no backblast at the shooter's end, generating no recoil force because the exhaust escaped from the rear, a launcher that transferred no force to the man holding it. A soldier standing upright with the tube on his shoulder would feel, when he pulled the trigger, the same sensation as pointing his finger. Uhl and Skinner tested the first prototype by firing it off a pier into the Potomac River. Uhl wore a welder's mask, expecting backblast. There was none. He felt only the weight of the tube, and then it was empty, and the rocket was in the river, and it had worked. They brought the prototype to Aberdeen Proving Ground in May 1942 for a scheduled demonstration of various spigot mortar systems, complex, heavy British-derived weapons that required trained crews and weighed over 100 pounds. The demonstration had been organized to show the assembled generals the most promising approaches to the anti-tank problem. Skinner and Uhl were not on the program. They arrived early. The demonstration began. 5 different spigot mortars fired at a moving M3 Stuart tank from the designated range. The weapons were heavy, their sighting systems complex, their trajectories unpredictable against a moving target. The generals watched. Not one mortar hit the tank. Then Uhl stepped to the line. He had fashioned the front sight that morning from a wire coat hanger bent to shape with a pair of pliers, because in the preparation for the demonstration, no one had thought to fabricate proper sights for the prototype. A coat hanger on the day that would determine whether this weapon was produced in the hundreds of thousands or discarded. The tube went onto his shoulder. He looked through the bent wire. He squeezed the trigger. The rocket hit the tank on the first shot. He reloaded in 5 seconds and hit it again. Among the assembled observers was Brigadier General Gladion Marcus Barnes, chief of the Ordnance Department's Research and Development Section. Barnes walked forward, examined the tube, and reportedly spoke 6 words that determined the weapon's immediate future. "It looks like Bob Burns' bazooka." Bob Burns was a radio comedian whose signature prop was a homemade musical instrument, a crude tube and pipe contraption he called a bazooka. Barnes was making a comparison, not a judgment. What he did next was the judgment. He took the launcher, aimed at the tank, and hit it on his first shot. Then he handed it to the next general. That general also hit the tank. The remaining rounds were divided among the assembled brass. The generals were hitting a moving armored target with a weapon they had never seen an hour earlier, using a sight made from scrap wire. On the first day the weapon had been brought out of the workshop. Barnes ordered 5,000 units that afternoon. General Electric received the production contract on May 20th, 1942. The contract specified 30 days to deliver the initial order. General Electric delivered the 5,000 M1 rocket launchers 89 minutes before the deadline. Every M1 bazooka required 20 pounds of steel, basic welding, and simple electrical components. Total production cost? $25. A factory worker could assemble one in approximately 2.5 hours. No special alloys, no precision machining, no exotic materials. A facility that made water heaters could make bazookas. The M6 rockets cost $8 each. This was the economic core of the weapon, and it was the dimension that the German engineers at Kummersdorf, with their excellent analysis of the launcher's specifications, had not fully absorbed. They had correctly assessed the armor penetration, the weight, the production requirements. What they had not assessed was the implication of that production cost for the scale of deployment. $25 per launcher. At that price, the Army could equip every squad in every infantry battalion with one. Not the anti-tank platoon, every squad. Any two soldiers, with an afternoon of training, could carry one anywhere infantry could go. Up a mountain, through a forest, into a building, across a river. And with it, carry the capability to kill the most expensive piece of hardware on the battlefield. That had never been true before in the history of infantry combat. The bazooka's first combat deployment was not a demonstration of this potential. It was a demonstration of what happens when a new weapon reaches the front without any preparation for its use. Operation Torch, November 8, 1942. 5,000 M1 launchers had been loaded onto the ships carrying the invasion force to North Africa. They arrived in sealed wooden crates, stamped "Secret," with instructions to remain sealed until the operation began. No training manuals were included. No instruction sheets. Not a single soldier in the entire invasion force, including the soldiers whose crates they were, had ever fired one. Imagine that situation from inside it. You are 19 years old. You are about to wade onto a hostile beach in Africa. You have spent months training with your rifle, your grenades, your machine gun. You understand your weapons. And then, at the moment when understanding your weapons is the difference between coming home and not, someone hands you a 5-foot steel tube you have never seen before and says, "This stops tanks. Figure it out." The 59th Parachute Infantry Regiment reported that of their first 20 rockets fired in combat, 7 functioned properly. 65% failure rate, under fire, on the day that mattered. Ammunition damaged by salt water during the sea crossing. Electrical contacts corroded by humidity. Soldiers trying to determine the firing sequence under fire. Some rockets detonated prematurely. Others did not detonate at all. And yet, even in the chaos of the first deployment, the 1st Armored Division's combat log for November 10th recorded, "Anti-tank team destroyed 2 Vichy French Renault tanks with new rocket weapon near Port Lyoté. Weapon effective when functioning properly." When functioning properly. Those 3 words contained both the promise and the problem. 3 months later, February 14th, 1943, Kasserine Pass, Tunisia. Rommel's Africa Corps struck the American Second Corps in what became the worst single defeat the United States Army suffered in the European theater. Over 6 days, more than 6,000 men were killed, wounded, or captured. 183 tanks lost, 200 guns. Among the equipment abandoned during the retreat were 5 intact M1 bazookas and approximately 20 M6 rockets. Some of the soldiers who left them had received the weapons 2 days before the German attack. They had fired them for the first time at the German armor that overran their positions. The captured bazookas reached Kummersdorf on February 28th. The Germans assessed them, understood them, and produced their copy in less than a year. Kasserine also produced a consequence its German observers could not have predicted. It forced the American Army to completely rethink how it introduced new weapons. The M6A1 rocket replaced the original M6, with improved contacts and more robust waterproofing. Training programs were redesigned so that soldiers qualified on the weapon before deployment. The weapon that had been handed to soldiers in sealed crates would, the next time it appeared in force, be in the hands of men who had spent weeks learning how to use it. The German Panzerschreck entered production in late 1943. By any engineering standard, it was a significant improvement over the weapon that had inspired it. The original bazooka's 60mm warhead could penetrate approximately 80 to 100 millimeters of armor at combat range. The Panzerschreck's 88mm warhead penetrated 160 millimeters, nearly double. The 88mm round could defeat the frontal armor of the Panther and come close to the Tiger's side armor. The bazooka, in its original configuration, could not penetrate either reliably from the front. On paper, in the specification tables, the Panzerschreck was the better weapon. In the field, in the mud and snow and destroyed buildings where it was actually used, the specification tables failed to capture what mattered. The Panzerschreck weighed 9.25 kilograms empty, nearly double the bazooka's 5.9 kilograms. The early models required the operator to wear a gas mask, heavy gloves, and a protective poncho before firing, equipment that added several seconds to the time between identifying a target and getting around on the way. The bazooka operator wore whatever he was already wearing. The Panzerschreck's rocket continued burning after it left the tube, creating a visible smoke trail that betrayed the firing position immediately. The bazooka's rocket completed its burn inside the tube. Anyone within 10 meters directly behind a Panzerschreck was at risk of burns. The bazooka could be fired from an enclosed space, a room, a bunker, a basement. The Panzerschreck could not. Germany produced approximately 289,000 Panzerschrecks during the war. American factories produced 476,628 bazookas, more, despite the smaller warhead, because the simpler design permitted faster, cheaper, more widely distributed manufacture. 289,000 weapons that burned their operators in enclosed spaces, against 476,628 weapons that could be fired from anywhere, in any condition, by any soldier who had received an afternoon of training. The transformation began in Sicily and was complete by Normandy, July 1943. The 82nd Airborne Division, now fully trained with the improved M1A1 bazooka using the more reliable M6A1 rocket, lands in Sicily as part of Operation Husky. They encounter the Hermann Göring Panzer Division. They also encounter, for the first time in significant numbers, the Tiger I tank. The Tiger was, in 1943, the most feared ground weapon the Allies faced. 57 tons, an 88mm gun that could destroy a Sherman at 2,000 yards, frontal armor 100 millimeters thick, sloped to deflect incoming rounds. There was nothing in the American ground arsenal that could stop a Tiger frontally at any realistic range. The bazooka could not penetrate the frontal armor. The Sherman's 75mm gun could not penetrate it. Near Biscari, in July 1943, a two-man bazooka team from the 82nd Airborne put a round through the driver's vision slot of a Tiger, a gap in the armor perhaps 4 inches wide, at combat range while under fire.
This shot requires an honest assessment. Hitting a 4-inch aperture at 50 meters while a tank is traversing its machine gun toward your position is not a repeatable tactic. It was not taught in any training manual. It was an act of extraordinary marksmanship under conditions that most people in that situation would not survive. But what it produced, in the German tank commanders who heard about it, was something that no specification could quantify. The Hermann Göring Division's war diary for July 11, 1943, recorded a warning that would have been unthinkable 18 months earlier. Enemy infantry equipped with rocket weapons capable of destroying armor at 100 to 150 meters. Tank commanders must exercise increased caution in urban areas. Tank commanders must exercise increased caution. The inventors of Blitzkrieg, the men who had turned armor into a force that operated independently, at speed, without waiting for infantry, were telling their tank crews to slow down. To be careful. to be afraid of teenagers with tubes. Colonel James Gavin of the 505th Parachute Infantry Regiment wrote in his after-action report, "The bazooka has given American infantrymen confidence against enemy armor. In Sicily, we destroyed 17 German tanks with bazookas. The psychological effect exceeds even the physical destruction. This sentence is the key to understanding what Eisenhower was describing 7 years later in Paris. The bazooka's strategic importance was not primarily in the tanks it killed. It was in the tanks that would not advance. Before the bazooka, a German armor column had a specific operational freedom. It could drive through contested territory, using its machine guns and its weight and its speed to push infantry aside. After the bazooka, the same column had to stop at every building, every hedgerow, every pile of rubble, and establish that no one was hiding behind it with a tube on their shoulder. Not because every hiding spot contained a bazooka, because any hiding spot might. In Italy, the soldiers discovered uses the training manuals had not anticipated. They called one technique mouse-holing. Rather than advancing through streets swept by machine gun fire, a bazooka team would blow a hole through the interior wall of a building, move through the opening, blow another hole, advance through an entire block without stepping outside. The 1st Canadian Infantry Division's war diary recorded, "American rocket launchers proved invaluable in street fighting, used against fortified houses with good effect." Fortified houses, machine gun nests, concrete pillboxes, bunkers, barbed wire obstacles. The weapon designed to stop tanks was stopping everything, snipers in bell towers. Crew-served weapons in reinforced cellars. Roadblocks constructed of rubble. Anywhere a shaped charge warhead at 300 feet per second could reach, the bazooka was producing solutions that the engineers at Indian Head had never imagined when they wrote the specifications. The Army's official after-action synthesis for the Italian campaign, produced in the spring of 1944, identified the bazooka's versatility as one of its most significant combat attributes, noting that units were employing it in anti-personnel, fortification reduction, and obstacle clearing roles at a rate that exceeded its anti-armor use. Soldiers in contact with the enemy found their own applications faster than doctrine writers could document them. This is, in the history of military technology, relatively rare. Most weapons are used more narrowly in combat than their designers projected. The bazooka was used more broadly. In December 1943, the Wehrmacht issued Training Directive 43/18, a document whose language is more significant for what it acknowledged than for what it prescribed. Tanks will not operate in urban areas without infantry support. All buildings must be cleared before armor advances. Minimum 100-meter distance from uncleared structures. Before the bazooka, a German panzer column drove through a town at speed. After the bazooka, it stopped, waited for infantry, cleared every building. A maneuver that took minutes now took hours. Speed became caution. Shock became hesitation. The fundamental arithmetic of blitzkrieg, move fast, hit hard, keep moving, was broken. A captured German document from the 2nd SS Panzer Division, March 1944, stated, "American rocket launchers present in every infantry unit. Speed and shock tactics no longer viable. Methodical advance with infantry screening required. Speed and shock tactics no longer viable." That is the epitaph of blitzkrieg, written by the men who invented it. June 6, 1944, Normandy. The soldiers wading ashore through the surf carried the M9A1 bazooka, the latest refinement, a two-piece design for easier transport, magneto-ignition that eliminated the battery failures that had caused the North Africa disasters, an optical sight replacing the wire sights of the early models. They were not the men who had fumbled with sealed crates 18 months earlier. They had trained with the weapon. They had fired it. They trusted it. The bocage country of Normandy was, almost by geological coincidence, the ideal environment for the weapon's deployment. Ancient earthen embankments, 2 meters high, dense with roots and vegetation, dividing every field from every other field, turning every lane into a corridor, every hedgerow into a potential defensive position. A tank driving through the bocage could see no more than one field in any direction. Behind every hedge, in every sunken road, in every ruin and barn and farm outbuilding, a two-man bazooka team could be waiting. Could be. Was not necessarily, but could be. That uncertainty was the weapon's greatest achievement. First Army records for the 6 weeks following D-Day show bazookas accounting for approximately 12% of all German armored vehicle losses in the American sector. 1 vehicle in 8, destroyed by a handheld weapon costing $25,
operated by 2 men who had received an afternoon of training. But that number understates the reality, because it counts only vehicles destroyed. It cannot count the vehicles that were not in the fight at all. The tank commanders who chose not to advance past a pile of rubble without infantry reconnaissance, who slowed their column at every shadow, who refused the assignment because they had heard what happened when a bazooka team was waiting in the right place at the right time.
A tank whose crew decides not to advance is, militarily, as absent from the battle as a tank that has been destroyed. The bazooka statistics do not capture it. The operational results did. The 29th Infantry Division's after-action report for June through July 1944 noted, bazooka teams operating in hedgerow country achieved high success rates against enemy armor. German tanks increasingly reluctant to advance without extensive infantry reconnaissance. Increasingly reluctant. 2 words that, in the context of an armored force whose operational doctrine had been built on speed and shock, represent a strategic transformation. December 21, 1944, Belgium, Malmedy sector, the Battle of the Bulge. The German offensive that began on December 16th was Hitler's final strategic gamble. 200,000 men, nearly 1,000 tanks, erupting from the Ardennes through fog and snow into the thinly held American line. The 106th Infantry Division, a green unit that had arrived at the front 5 days before the attack, was shattered in the first 48 hours. 2 entire regiments, the 422nd and 423rd, were surrounded. More than 8,000 soldiers walked into German captivity, one of the largest mass surrenders in American history. The weather favored the attacker. Fog and overcast eliminated the air power advantage that had been central to American operations since Normandy. The German armor, for the first days of the offensive, operated without the constant threat of fighter bombers that had transformed the summer campaign. The infantry that faced those tanks in the opening days of the Bulge was often doing so in conditions where the only anti-armor weapon available was the one 2 men could carry. Technical Sergeant Donald Bracken of the 394th Infantry Regiment destroyed a Panther tank near Rocherath on December 17th from approximately 75 yards, less than the length of a football field. His account, recorded in the 394th's after-action reports, described waiting in a frozen foxhole until the Panther was close enough that the backblast from the rear engine deck shot would be the killing mechanism if the warhead itself did not penetrate. The tank caught fire. The crew abandoned it. The range at which Bracken had to engage, 75 yards, allowing the tank to close until a miss would leave no time for a second shot, was not unusual. Most bazooka engagements in the Bulge happened at distances between 50 and 100 yards, measured not in tactical preference, but in the geometry of survival. Get close enough to be certain, get away fast enough to survive. Private First Class Francis Curry was 19 years old. He served in Company K, 125th Infantry Regiment, 35th Infantry Division. He was an automatic rifleman, not a bazooka gunner. The bazooka he used that morning was not his assigned weapon. On December 21st, a German armored column hit his position in the Malmedy sector. 5 of his comrades were trapped in a burning building. His squad was pinned. The tanks were closing. Not 1 or 2, but a column, grinding forward through the snow. Curry found a bazooka. What he did over the next hour is documented in his Medal of Honor citation and confirmed by multiple witnesses. Moving into exposed positions under direct fire, he hit a German tank. The crew abandoned it. He found more rockets, reloaded, engaged a second tank, then a third, then a fourth. 4 tank crews, each capable of destroying his entire company, forced from their vehicles by 1 man who had picked up a weapon that was not his assignment, because it was there and the situation required it. Then he went into the burning building and brought out the 5 trapped men. He received the Medal of Honor on July 27, 1945. He was among the youngest recipients of the war. The older M1 bazookas still in service used battery ignition, and soldiers in the Ardennes winter learned to carry the batteries inside their jackets against their bodies, transferring them to the launcher only at the moment of use, because batteries at -20 degrees Fahrenheit did not fire reliably. The rocket propellant burned differently in extreme cold. None of this was ideal. All of it was manageable, because the weapon was simple enough that its failure modes had simple workarounds. This is the attribute that no specification table captures. A weapon complex enough to require ideal conditions fails when conditions are not ideal. A weapon simple enough to work in a soldier's jacket in sub-zero temperatures, with improvised workarounds developed by the men who used it, works everywhere. The full economic accounting that Eisenhower was describing when he placed the bazooka on his list can now be stated precisely. The cost of destroying one German tank using American tanks? Approximately $187,000. 2.5 Shermans at $75,000 each. Using artillery? Approximately $45,000. Using aircraft? Approximately $85,000. Using bazookas? 5 rockets at $8 each. Occasional launcher loss, approximately $50. $50. Against $187,000. A Tiger tank cost the German economy approximately $100,000 in equivalent currency. For the price of one Tiger, the American Army could purchase 2,000 bazookas and 20,000 rockets, enough to threaten any single Tiger 2,000 times over, distributed across every infantry squad in a division. Germany produced approximately 1,400 Tigers during the entire war. The 15 million rockets manufactured by American factories were, by the 5-rocket average for a bazooka kill, sufficient in principle to destroy every Tiger ever built 4 times over, and still have enough remaining to destroy every Panther, every Panzer IV, and every assault gun in the Wehrmacht. The 237 subcontractors across 34 states who manufactured bazooka components were distributed widely enough that no single Allied bombing campaign could have significantly disrupted supply. Unlike German production, which was concentrated in facilities that Allied bombers could and did target, the bazooka's manufacturing base was the American industrial fabric itself. Too distributed to attack, too redundant to disrupt. The bazooka's direct descendants are present in every conflict zone today. The M72 LAW, the AT-4, the Carl Gustav recoilless rifle, the Soviet RPG series, whose lineage runs directly through the Panzerschreck to the captured bazookas at Kasserine. Every time a news broadcast shows a soldier with a tube on his shoulder, you are looking at the geometry that Edward Ohl saw in a scrap pile in Maryland in 1942. A rocket, a tube the same diameter as the rocket, and the understanding that if the burn finishes inside the tube, the man holding it feels nothing. Every military in the world understood the implication within years of the war's end. Infantry anti-tank capability, once the province of specialized crews with heavy equipment, was now a standard attribute of every squad. The infantryman who could not stop a tank before 1942 could stop one after 1942, at $25 per launcher, anywhere he could carry himself. The full forensic record assembles as follows. In the spring of 1942, Lieutenant Edward Ewell of Elizabeth, New Jersey, Lehigh University, class of 1940, walked past a scrap pile in Indian Head, Maryland, picked up a 5-foot steel tube, and understood, in the specific way that engineers understand things, not as inspiration, but as geometry, what it could be made to do. He died in 2010 at age 92. His obituary in the Washington Post ran 300 words. The weapon he and Colonel Skinner built was $25 per unit, 5,000 units ordered the day it was demonstrated, delivered by General Electric in 30 days, 89 minutes ahead of schedule. In production from June 1942 to May 1945, with 476,628 launchers and 15 million rockets manufactured across 237 subcontractors in 34 states. Distributed to every Allied nation through Lend-Lease, reverse engineered by Germany, copied, improved in specifications, made less deployable in practice, and produced in lesser quantity. Responsible for approximately 12% of German armored vehicle losses in the Normandy sector in the first 6 weeks after D-Day. Present in the hands of every American infantry squad. Credited in the post-war testimony of German commanders with invalidating the operational doctrine that had produced the Wehrmacht's greatest victories. Against this, Germany had the Panzerschreck. 160 millimeters of armor penetration, 289,000 units, gas mask required. The Panzerschreck was the better weapon. It penetrated more armor, It destroyed more tanks per round fired in the narrow window of direct comparative engagement. It was also the story of the German war in miniature. Build the best, build fewer, build something that requires its users to wear protective equipment. Build something that cannot be fired from a cellar.
Build something that is technically superior and operationally inferior and produced at half the scale of the simpler version your enemy made from a scrap pile with a coat hanger for a sight. Eisenhower placed the bazooka alongside the atomic bomb because he understood what the atomic bomb and the bazooka had in common. Not the scale of destruction, the scale of decision. The atomic bomb ended the war with 2 weapons deployed against 2 cities. The bazooka changed the nature of armored warfare across every theater, every campaign, every engagement where infantry faced armor for 3 years. It did not do this by being the best anti-tank weapon. It did it by being the most present, the most distributed, the most affordable, the simplest to use. The atomic bomb changed history because of what it destroyed. The bazooka changed history because of what it was available to destroy, everywhere, at any moment, in the hands of any 2 soldiers who had spent an afternoon learning to use it. 2 different methods of changing history. Eisenhower had the intellectual honesty to see that both belonged on the same list. In 1943, General Guderian had written in his theoretical work on armored warfare that armor's decisive advantage was the psychological effect of its presence, the terror that preceded it, the paralysis it produced in infantry that had no response to it. By 1944, German tank commanders were hesitating at hedgerows because of the possibility of a steel tube in the hands of someone they could not see. Panzer columns that had crossed France in 6 weeks in 1940 needed infantry screens before they could pass a pile of rubble in 1944. The terror had changed sides. It cost $25. Edward Ewell returned to civilian life after the war and joined Fairchild Industries, where he eventually became president, chief executive, and chairman, a trajectory from lieutenant to the leadership of a major defense contractor that was, in post-war America, not unusual for the engineers who had won the war. Under his leadership, Fairchild developed the A-10 Thunderbolt II, the close air support aircraft nicknamed the Warthog, which destroyed Iraqi armor in the Gulf War in 1991 using a 30mm rotary cannon capable of penetrating the top armor of any tank then in service. Ewell had spent his entire career finding ways to kill tanks. He was consistent in his interests. He died on May 9, 2010, in Easton, Maryland, at 92. His Washington Post obituary ran approximately 300 words, most of which concerned his work at Fairchild. The bazooka was mentioned in the 3rd paragraph. The coat hanger sight is not mentioned. Leslie Skinner, who gave Ewell the assignment and recognized what they had on that pier over the Potomac, retired as a colonel. Brigadier General Barnes, who ordered 5,000 units on the afternoon of the demonstration, and whose immediate recognition of what he was seeing was the proximate cause of the weapon's production, is remembered primarily in ordnance history. The German Tank Museum at Munster has a permanent display on anti-tank weapons that includes the American bazooka. The museum's placard reads, "The American M1 rocket launcher revolutionized anti-tank warfare. Simple, cheap, and effective, it could be operated by any soldier with minimal training. By war's end, the presence of bazookas in every American unit had neutralized German armored superiority." A German museum, about an American weapon that cost $25. The Germans named their copy Tank Terror. They were describing the weapon that was pointing at them.